This is Key Assessment 3 for Lower 6, Core Concepts, and it's paper 2, and the Help Me video. So, quite a scary question this. A full page of information. Right, what do we know? What do we recognise? So we recognise lipase, that's an enzyme, it's got A's at the end of it. And other things I recognise is hydrolysis, that's a reaction, triglyceride fats, so I recognise that. And then some lipases act in compartments in cells, so inside cells, well, the work extracellular. And you might remember this from GCSE, but extracellular enzymes, and the other ones are the ones that work inside. So intra, yes, intra, not inter. Inter means between, and intra means within. So that's a pretty tough word to think of, that. We've got an experiment here. This is a little bit like a biochemistry experiment you may have done with lipases and milk with indicator that changes colour. So it's a similar thing, and you've used a colorimeter as well. So what they're doing here, they're mixing. They have got a tube, and what they're putting in 2 cm³ of triacetin. What's that? That's the fat. So they're putting the fat or the lipid in there. So fat or lipid, and the 3-sodium hydrogen carbonate plus the alkalis in there as well, and indicator. So at the start of this experiment, they've got the fat, which is the substrate, so in enzyme experiments, again, it's always helpful again to go, do I know what the substrate is? So that is our substrate, that's our enzyme. Okay, and product, we don't know yet. So set up that tube, and they've got a separate tube, and they've got the lipase, which is the enzyme. So 2 tubes, substrate plus an alkali plus an indicator, and then a separate tube they've got an enzyme. And they're going to get these to the right temperature, mix them together, and the enzyme is going to work on the substrate to produce the products, and this indicator will change. And that's what we're detecting over here, the colour change. And they're doing this, the timing, how long it takes for the light sensor to get to 0, the absorbance, and they're repeating it and doing it over different temperatures. So a lot of this is, you know, experimental work, and you're nearly always having to think of independent variable, dependent variable, and controlled variables. The independent variable is the one that you are changing. I for independent, I decide this, I change this, and that's going to be our step 7, where it says the repeats at certain temperatures. So we've got original temperature, and these are the temperatures. The dependent variable is the thing that we are measuring. So you just need to say exactly as it is there, step number 5. Over the page. Why were the solutions left for 5 minutes before mixing? Well, when you get the solutions, out of the fridge or wherever, they might be at 5 degrees, and this temperature that you're performing the experiment at is different to that. So you just need to explain why you'd heat it up to the right temperature first. Try and use the right scientific word for getting it to the right temperature. There's a couple of different words you could use. Why would we not want to use buffer solution? And 3 marks, so you need to say 3 separate things there. And really, it interferes with our dependent variable. So you need to ask yourself, why is this solution changing colour? So the indicator is a certain colour when it's alkaline, and then the experiment is going to run with the enzyme working on the substrate, and then it's going to change from an alkali, and the indicator is going to indicate that. So if you put a buffer in, it's just going to keep the same pH. That's what a buffer is. So a buffer keeps the same pH, which would mean the experiment didn't work. So you just need to try and put that into 3 separate sentences for an explanation. Here's our results. And we've got the temperature, and this is the time taken for the kind of reaction to happen. So at the start, so at a low temperature of 20, it took a long time for the colour change because it was slower. And that ties in with what we know about enzymes and temperature. And then as it got warmer and warmer, it took less time, so it was faster, so it took less time. And then we've got a 3-mark calculation. In this experiment, we used this volume containing, this is the concentration, and that's the substrate. So that's our substrate, that is a volume, and that is a concentration. And we are asked to calculate a rate, and that's the temperature. Okay. And we are going to remember to give this in standard form. Okay, so it's not easy, this, and we need grams per second. So there's 2 things here. Rate is something per unit time. So let's deal with the time first, perhaps the easier one. The time. So at 40 degrees. So 40 degrees, here's our graph, so we're going to go up like that, and at 40 degrees, if we went across, you do this with a ruler, exactly, but you can see at 40 degrees the time taken, 18 seconds, so mean time taken is 18 seconds. You could say 18.5, or you could go either way a little bit and not really get penalised. But 18 seconds. So, grams. How many grams have we got? Well, how many grams have we got? We've got 2 cm cubed of 0.25 grams per cm cubed. So if we had 1 cm cubed, we'd have 0.25 grams. But we've got 2. So we've got a 0.25, and we've got another 0.25 because we've got 2 cm cubed. So the total is 0.5 grams. And so your calculation is, I've got 0.5 grams took 18 seconds. So we've got 0.5 grams took 18 seconds. So how much would you get per second? Well, it's 0.5 divided by that 18, and then you just need to put it into standard form. So hopefully that will enable you to come up with a number there. Suggest one source of inaccuracy in the method. So let's go back to the method. So they're heating up the tubes, then adding them together. So they could possibly hard to maintain the temperature. So always think about these controlled variables. Hard to control the temperature. Think about volumes. What did they use to measure the volumes? They could be inaccurate in some way. Did they transfer everything that they wanted to? So some suggestions along those lines, and you only need one good suggestion there. It was not possible to determine the optimum temperature for this enzyme. Why? Well, what would we, if we did a sketch of this graph underneath? So here's the graph that we've got going like that. What would we expect at higher temperatures? Where would this graph go? Well, you think as the temperature gets higher, we got denaturing. It would start to take longer again. So we might expect this graph to go back up again if we extended it like that. So when it's really cold, it takes a long time. When it's really, really hot, it takes a long time. And in the middle somewhere, that's the optimum temperature where it's not going to take a long time. So what's wrong with our experiment? Well, it's still going down, isn't it? So the optimum temperature is maybe here somewhere, 55 possibly. But we haven't got that range of temperatures yet. So we need to extend this range. And then around the optimum temperature, you could do with, we're doing it every 5 degrees. Well, what happens if it's in between those? So maybe more values in between. So that's the start for your explanation, and just try and explain those points. 50 marks, a good experimental question.